Hi guys, let's talk about what we're doing today. Today you're going to come here under April 3rd, click on these heat nodes. I'm just going to go through some of these slides. It says heat is a type of energy, all right, and the units are joules. So essentially heat, it transfers from hot surface to a colder surface, okay? And the heat transfer, or different ways you can heat is transferred. The processes are called conduction, convection, or radiation. Conduction is when you take a pan and you put it on the stove, it's getting direct heat. That's conduction. Convection is when the water molecules are transferring heat energy to each other. That's convection. And then radiation is in the air. Okay, the heat is being radiated in the air. All right, so temperature. Let's talk about it's not just hot or cold. You already know this because we've done the heating curve, all right, in previous units. So you already know this stuff. It's just basically temperature is average kinetic energy of the molecules. Okay, so different units are Celsius, Fahrenheit, and Kelvin. Let's look at the stuff that you're doing today. Specific heat is the amount of heat needed to raise the temperature of 1 gram of the material 1 degree C. Let's make sense of this. What does this mean? What it means is that compare this iron numbers right here, 0.45, and then water number right here, 4.18. If I have an iron skillet, I put it on the stove, I want it to get hot really, really quickly. So specific heat, or this C, specific heat symbol is C, okay? The specific heat 0.45 means that lower the number for specific heat, the hotter the object is going to get quickly. Okay, so the lower the number for specific heat, the hotter the object is going to get quickly. So if you have a copper pan, it's going to get even hotter quickly than iron is, okay? Now compare this to water. Water heat capacity is 4.18, which means that if you take water, put it in a pan, it doesn't get hot quickly, right? So it needs all that time, all that heat to raise the water temperature or get it to that boiling gas phase, okay? So 4.18 makes sense because it's got a bigger heat capacity, which means it needs to take in more heat, okay? Iron, on the other hand, 0.45, smaller the number. You want it to have smaller number because I want my iron skillet to get hot quickly so that I can make my pancakes. All right. Let's look at the formula that you're going to use. The formula that you're using, Q, is heat. Anytime the questions are going to say heat or thermal energy, that's Q. You have mass times C, which is heat capacity, times change in temperature. All right. So let's scroll down here. How much thermal energy is needed to raise the temperature of 400 grams of water from 21 degrees C to 100 degrees C? Q is heat or thermal energy. Mass is 400 grams. C is the heat capacity of water, which I just told you is 4.18. It's right here, 4.18. Okay, so remember that number, write it down somewhere. I'm not sure if every problem gives you the heat capacity, but that's the number you're going to use, 4.18 for water. And the temperature change is happening. The temperature went up from 21 to 100, okay? So your change in temperature, or delta T, is going to be final, which is 100 minus 21. 100 minus 21, okay? So that's how you're going to do change in temperature. And that's 79 degrees Celsius. So your Q is going to be mass times heat capacity times change in temperature. Don't just take one of these temperature, do change in temperature, and you're going to get your Q. Okay? Now, let's see. What do we have next here? Let's go back. We have heat calculation worksheet, and I went ahead and pulled that up already, okay? So you're going to be doing this right here, heat calculation worksheet. Once again, to make things in life easier for you, I went ahead and manipulated the equation for all of these variables right here, okay? So, and I went ahead and did the first problem. Let's talk about that. Gold has a specific heat. Notice the specific heat is symbol. Symbol is C, specific heat symbol, and I give you all that. Specific heat symbol is C. So C is 0.129 joules per gram degree C. And yes, all those units are going to be part of C. I went ahead and put that here, okay? How many joules of heat energy are required to raise the temperature of 15 grams? My mass is in grams, and that's 15 right here. Required to raise the temperature of 15 grams of gold from 22 degrees C to 85 degrees C. So your final temperature is going to be 85 minus 22. Change in temperature is 63. Not final temperature. This is your final. This is your initial. You're going to subtract these two, and that's the number you're going to use, 63 degrees C. And here's the formula for Q. Okay, because it's asking you to find how many joules of heat energy, and that's Q. Mass times specific heat, which is C times delta T. Mass times specific heat right here, 0.129. Mass is 15 times 63 degrees C, and that's your answer. And notice I put J because Q is in joules. Okay, I hope this helps. Let me know if you have any questions. Reach out to me. And I hope you all can join us for the Zoom call that I scheduled for 2:30 today, okay? See you guys later. Bye.